Welcome to Geometry SOL Review for Quadrilaterals. Notice all of these are types of quadrilaterals. Now soon we're going to zoom in so we can see specifics, but notice that the parallelograms, all of these are grouped together. These are all types of parallelograms. Then you have the trapezoids that are grouped, and you have the kites. So all of these are parallelograms. They all share similar properties. The trapezoids are not parallelograms, and the kites are separate from both, but they are all types of quadrilaterals. Remember, quad is a prefix that means four. So let's take a closer look at the parallelogram side of the story. These are all of the properties of a parallelogram that are important to memorize. So we've got the fact that opposite sides are parallel. Let's make a note that when we see parallel, we think same slope. So for example, this side has the same slope as this side because they are going in the same direction. So if this slope was 1/2, this slope over here is also going to be 1/2. We will also remember that opposite sides are congruent, so this length is the same as this length. Opposite angles are also congruent. Adjacent angles are supplementary. So remember, supplementary means that they add up to 180 degrees. So the angles next to each other, adjacent angles, such as this angle and that angle, together those will add up to 180 degrees. Then we have the diagonals bisect each other, and one pair of sides has to be both congruent and parallel. Now we come to the rectangle, where it is a type of parallelogram, so all of these properties apply, but also all the angles have to be congruent and they measure 90 degrees. So there are 4 right angles in all rectangles. See the word angle in rectangle? That'll help you remember that the angles are congruent and 90 degrees. Now that's helpful for when we need to think about the slope. When we see a 90-degree angle, that means the slopes of the sides that are next to each other, like this side and this side, have to be opposite reciprocals. So for example, the slope of this side, let's say that that slope was 1/2, then the slope of the side next to it would be the opposite reciprocal of that, -2/1. Let's move on down to see about the rhombus. Now a rhombus is also a type of parallelogram. So again, all of the parallelogram properties apply, but also all the sides are congruent. So 4 congruent sides. The diagonals are perpendicular. So when we see perpendicular for the diagonals, remember, think 90 degrees and think about what that means about our slope. And the angles are bisected by the diagonals. Now you have a square, which is the parallelogram, rectangle, and the rhombus. So everything from above applies, where all the sides are congruent, all the angles are 90 degrees. Remember what the 90 degrees means about our slope. The diagonals will be perpendicular, congruent, bisect the angles and each other. Basically, the square has everything. Let's go ahead and take a look at the trapezoids. A trapezoid is when you have one pair of opposite sides that are parallel. So this side right here, parallel to this side right here in the picture. So those would have the same slope. Each leg has supplementary angles. So remember what we said about the supplementary, that means they add up to 180 degrees. So this is a leg, and this is a leg, and those angles that are on that leg are going to add up to 180 degrees. An isosceles trapezoid is a specific kind of trapezoid where one pair of opposite sides is parallel, of course. One pair of opposite sides are congruent. So this time you do still have these parallel sides, but now you've got also the legs that are congruent to each other. The base angles are congruent, so that angle to that angle, and that angle to that angle. The leg has supplementary angles, of course, like the trapezoid, and the diagonals have to be congruent. Finally, you have the kite, and a kite is special because it's not about the opposite sides, it's about the consecutive sides being congruent. So see, this short side and this short side are congruent. This long side and this long side are congruent to each other. One pair of opposite angles are congruent. So this angle across from this angle, those angles are congruent, and the diagonals are perpendicular. So remember, when you see perpendicular, you think 90 degrees, and remember what that means about the slope. Let's take a look at some examples. Remember that when you start the problem, look to see which of the shapes you will be solving with to know its properties. Example 1. Parallelogram ABCD is a rhombus with the measure of angle EBC equal to 36 degrees, like they showed in the picture. What is the measure of angle DAE? So the way we say that, we can draw that. DAE. Stop there, and we see that this is the angle we're looking for. I'm going to put a little X there because that's what I'm trying to find. Now we remember that because it's a parallelogram, the opposite sides are parallel, so I can make the zigzag shape for the alternate interior angles over the sides of the rhombus, and that tells me that this angle, which is 36 degrees, is congruent to this angle here. So I'm going to write 36 degrees in that angle. Also, because I have a rhombus, I know that the diagonals are perpendicular. Perpendicular means that there's a right angle here. So notice that I've got this triangle here. And it's important to see we have a triangle because we have to remember that the angles inside a triangle add up to 180 degrees. So the x plus the 36 plus that 90-degree angle right there equals 180 degrees. So we can solve for x by combining like terms, subtracting 126 from both sides, and then x is 54. So the angle we wanted, 54 degrees. Let's take a look at the next example. The diagonals of rectangle KLMN intersect at the point 2, 1. One of the vertices of rectangle KLMN is located at -4, 5. Which of the following could be the location of another vertex of this rectangle? Let's start plotting what they gave us. So we have the point 2, 1. That's where the diagonals intersect. And the vertices, one of the vertices, so in a rectangle, the point where two sides come together, that's called the vertex. So -4, 5, -4, 5 is one of the vertices. This is where the diagonals intersect. Now, if we draw the diagonals of a rectangle, the diagonals have to bisect each other because in a rectangle, that's what they do. The diagonals are congruent and bisect each other. So that means from the vertex, that would be in this picture up here, to the point where the diagonals intersect, that's going to be halfway down to the other vertex. So I could do some counting, or I could graph each of these choices and see what makes sense. If I count from here to here, it looks like 1, 2, 3, 4 down, and 1, 2, 3, 4, 5, 6 to the right gets me from the vertex to the middle of the rectangle. So let's count that again. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. And there's another vertex of the rectangle. Let's see, does 8, -3 make it to one of our choices? And I do see it there. Example number 3, in rhombus, ABCD, AC equals 30, this is 30 inches, and BD equals 40 inches. So this is 40. Now because it's a rhombus, we know that it has a parallelogram property that the diagonals bisect each other, but they are not congruent. So if A to C is 30, and we cut 30 in half, half of 30 is 15. So this is 15, and this is 15. I'm going to label my picture. BD is 40, and half of 40 makes 20, so this is 20, and this is 20. The question says, what is the perimeter of the rhombus? Remember that perimeter means that we want to add all the sides. So we need to know how long is this side, this side, this side, and this side. But of course, because it's a rhombus, it means it has all congruent sides. So we have to find out one of the sides. Now we also remember in a rhombus that the diagonals are perpendicular. So if I put a right angle here, I'll notice that I have a right triangle. So again, we have to know some things about triangles. I'm going to draw this picture to the side, my right triangle, where this side is 15, this side is 20, and I don't know how long this side is. For now, I'm going to call it x. Because it's a right triangle, I can use my Pythagorean theorem, c squared equals a squared plus b squared. They put it on the back of our formula sheet to help us. The c is across from the right angle, and it's the slanty side. So x squared equals 15 squared plus 20 squared. So x squared equals 225 plus 400. So x squared equals 625. I take the square root of both sides, and x equals 25. So that means this side is 25, therefore all the sides are 25. And because I want to find the perimeter, I know it doesn't make sense that I would pick 25 because I have to add all the sides. So 25 added up 4 times, which would be the same as 25 times 4, or 100. Thanks for watching.